Okay, so today I guess we've sort of already met a little bit with me jabbering on there, but I'm Nick Harris. I'm a Windows Azure Technical Evangelist. So I now reside in Redmond. Who here thinks that I'm British? Just out of interest, show of hands, anyone? A couple of people. Ah, damn it. Yeah, no, pretty much I grew up in Australia, but everywhere I go, people ask me if I'm British, including British people. Where in Britain are you from? So I really don't understand that, but I'm glad that not many of you thought I was British. I'm actually Australian. But today we're going to talk about building connected Windows 8 apps with Windows Azure. Fancy transitions. I didn't do them myself. I don't know how they got in there. But today we're going to look at basic connectivity. How do we build a Windows 8 application that can consume resources from Windows Azure that are hosted up in an ASP.NET Web API service, and how do we go and store images to, say, blob storage? How do we store location-based information in SQL Azure? On top of that, we'll look at how we can add push notifications to our sample application at the end. So basically, we're going to build out an app that allows you to take a picture, upload it to Azure into blob storage, add a point of interest that is related to that picture, which essentially says this picture was taken at location latitude X, longitude Y. And then on top of that, we're going to thumbnail the images we're taking and send them as push notifications to the Windows 8 start screen. So let's go through the fundamentals. Most of you had said that you'd sort of covered this off either through watching Scott Guthrie's keynote or attending one of the Learn Windows Azure sessions yesterday. But our basic compute options for Windows Azure are varied. So if we looked at traditional on-premises today, when you're building out applications and you've got your own, say, rack in your data center, you're pretty much managing everything in the stack from the hardware all the way up through to the application. So there's a lot of things there to manage, and you need to sort of know everything from, as I said, hardware through to software. With Windows Azure, we've got a few different options for compute. We've got virtual machines. So this one pretty much is most flexible in terms of you have control over everything from the OS through to the application. But not all applications require that amount of control. So the next one we've got here is cloud services. So cloud services just bumps it up the stack one more, and essentially you just build out an application that can be published to a Windows Azure cloud service, say a web role or a worker role. And in this case, we, Microsoft, manage the OS for you. And the last but newest one, which we saw in the keynote, was Windows Azure Websites. This one's pretty much a way where you just build out your applications, you worry about what data you consume and where that's coming from, but you don't need to worry about anything else in the stack, and you can just publish that straight up quite fast. Today we'll probably do that towards the end of the session if we don't run out of time. But who here saw Scott Guthrie publish the basic ASP.NET website up to, okay, most people, everyone. Should have said who didn't. That's basically our cloud compute options, and we'll use some of that today. Our basic storage options in Windows Azure, the first three there are what we call Windows Azure storage. So we've got table storage. So that's good for storing non-relational data that can be massively scalable. We've got Windows Azure Blob storage, which we'll use today. That's best for storing images and any kind of sort of binary data, be it small to big files. It could be a video, it could be a Word document, it could be some XML. Windows Azure Queues, good for persistent async messaging, particularly in scenarios where you're architecting, say, a decoupled solution where you have, say, perhaps a web role that's pushing messages into a queue and a worker role that can scale out independently to go and process those messages. And the last one here in our sort of fundamental or core storage offering is SQL database. So I may refer to this as SQL Azure. If I do, you can boo me because I'm not using the marketing official terms there. They've renamed it to SQL database. But we'll see how I go. But essentially, all your existing skill sets in terms of writing T-SQL stored procedures, creating views, tables, all that sort of stuff is directly transferable to this. In actual fact, it's built on top of the SQL Server engine, and it's for the most part, identical. So that was our Windows Azure side of things, what we're going to do today. But the fundamentals we're covering in our Win8 Metro apps is everything there on the right. So if we're developing a Win8 Metro app, we have a few different language options that we can go and build that in. The first one's JS HTML. We could do C# XAML or C++. But all of these languages all call into the common WinRT API that provides a nice API for us to start interacting with device peripherals and, say, the network and those sorts of things. So we'll use the camera and location today for that. So on the right there, these are the main classes we'll be using. We'll be using HTTP client to call into our services. We'll use camera capture UI to capture media. We'll use geolocator for location. And we'll use the push notification channel manager for push notifications. So with that, let's talk about basic connectivity. I rushed through that so we can spend more time on the demo. But basic connectivity, we're going to start with a demo. So we'll build something here. Before I start, how many of you guys are like C# XAML guys versus JS HTML? So C# XAML? Okay. JS HTML? Okay, you guys can stay. I'll allow it. No, that's fine. But yeah, today all the demos I've got in XAML C# because that's sort of my language of choice. But that's one of the great things about Win8 Metro apps is you can program in what's familiar to you. Sort of got a weird-hearted desk here because I can't exactly sit because you won't be able to see me, and I can't exactly stand. So I'm going to do a hunchback for an hour and 15 minutes to build out these apps. So let's start with our services. So let's call it server. Don't know where that beep come from. Looks like I've lost my network. Let's resolve that quickly. That probably won't work well for our cloud stuff. There we go. That's fortunate. So does anyone want to sort of throw in a word I can put on the starter server here? Anyone? Throw out a verb or a noun. Nothing? Come on, guys. How much were you partying last night? Party server. Awesome. That's a good idea. Okay, so we're going to call it party server. You can see I'm using .NET Framework 4. So in Windows Azure at the moment, you can't run .NET Framework 4.5. That's just because it isn't GA as such yet. As soon as that happens, you can expect that you can run 4.5 up on Azure. So for our default services project, we're just going to create a basic web API here. So who here has not used web API? All right. Of those people, have you used WCF? All right, about the same amount of hands. So web API is essentially a lightweight method or a lightweight framework where we can expose HTTP endpoints to be called into from basically anything that can support a HTTP web request. So be that your Windows 8 clients or Windows Phone or even iOS or Android apps. So the services we're building here today can actually be consumed by quite literally anything. We're just choosing Windows 8 in this case. So is the font size all right up the back? A little bigger? All right. Let's go here. I can do 13. Don't crash my Visual Studio. How's that look? Bigger again? It's okay? Anyone want larger? Just want to make sure this is right because we're going to have quite a lot of code. Okay. So this is basically a default API controller it drops in. So if you're MVC developers, you're probably familiar with controller, which is more for your MVC applications, returning HTML or whatever to be rendered on the UI. API controller is essentially a web API. So you can see by default in this sample here, it's putting some basic get, post, put, and delete methods. This allows us to go and actually call into these using basic HTTP get, post, put, or delete semantics. So let's add a client application and just write a little bit of code to call into that basic web API. So for the client, we use .NET 4.5, of course. We'll start with a blank app. Party client. There we go. Okay. So that's our client up there. So let's get coding. I do have snippets for later on, but I think for the basics, we'll just type it out because it's only a few lines of code. So we're going to use a client, and we're going to use HTTP client. So this HTTP client is essentially a nice little wrapper that allows you to easily perform those get, post, put, and delete operations. So essentially it's just setting the header for what type you're using. Bit easier to use than the basic HTTP web request when you're calling into sort of web API or REST-based services. So let's set the response here. Equals client.getAsync. And that needs to go to a request URI. We'll pull that in a second. So our request, we're going to be running locally here on localhost for now, but this website or services we're building can essentially be deployed to Windows Azure websites. So by convention, to call into our values controller, we call into API/values. So you can see that I've gone to localhost there, and we've got API-values. Now this is an async method. So to call an async method, we can use the async syntax. So basically what this does is any code following the await is wired up as a continuation so that when the call completes, it'll be executed. So it just provides a bit nicer syntax for doing that. So I'm not sure if you guys have used like, what's it called? Action. I was coding and thinking and that doesn't work. So like if you're wiring up like a callback of some form where you're doing like a plus equals delegate or passing in an action method, it just removes the need to do any of that. So let's actually call this and say, so we've called client get async, we've got a response object, and now let's say we want response.content.read as string. So that's basically our first easy demo. Now, the reason I sort of chose to throw this in is just to show you the basic method that we're going to be using to call into all the services we build out later. The services we build out later will be a little bit more complex than this one, obviously. But I guess it's great to have the fundamentals down pat before we start. So there's our web API. We could do this. Navigate to web API.values. You can see that's returning a JSON response. And that's just what's returned from this get operation. So if we run our client application, we'll hit our breakpoint and we'll see that return back. So there we go. And there's our result. You can see the result over to the right is value 1, value 2. Oops. All right. So I missed an... Essentially, when you call an async method like this, it returns back a task. So this is actually a task or an instance of a task which has a result. If we want that to just drop straight into the result, we can just await that as well. Gosh, you'd think I'd know the basic 101 stuff. Yeah. So let's run that again, because I really want to show you something key and fundamental to developing any mobile application that I'd really like you to take away from this session. So that's the result, and it's a JSON string. If we say what's the length of that, it's 19 bytes. So most people, when they're building out services, or what was common historically is essentially let's return XML. So how many people have services that are returning XML to client applications? Awesome. So XML is great. It's really readable. How many of you guys actually read what's being passed back over the wire? Couple people? All right. That's good. But what I'd like to show you is that there is, and when you're building out sort of cloud-based services, you need to sort of realize that your serialization format has a cost. So I'm just wiring this up now to essentially return back XML. If I hit start, we'll see what that cost is. So client should hit that breakpoint. So there's our XML result. See result.length. It's 195. So that's about 10 times different. So Doesn't really matter on small scale things, but when you start building larger scale applications, and particularly if you're hosting them in any type of web farm or cloud provider like Windows Azure, there's a cost to that. So let's say if we were using JSON, and we've got, say, one instance or two instances of our website or our web role up and running in Azure, that's got a limited network I/O. Any computer, for that matter, this one here sitting on the desk, there's a cap or a level where our network is going to max out. So if we consider, if we're using JSON and we have, say, one web role, we may be getting, say, 1 million requests. If we were using XML for that one web role, we'd be getting around, in this scenario, 1/10 of the throughput. So you'd have to scale out 10 more instances to be able to handle that sort of throughput if you had, say, XML as your serialization strategy there. So what that means to you, end of day, is there's a cost associated with that as well. So when you build out these services for scale, you should really sort of consider that serialization format does matter. So I'd like you to take that away from today's session. So that was a basic web API. Let's jump into media pretty quick here. So media, we're going to show how we can capture it on our Windows 8 application, how we can upload it, and then, again, how we can download it to view. So, sorry, forgot my slides. A bit of fundamentals, or 101. So the way I like to do this for each section, I'm just going to show you the basics that I think you should know before we start coding. And one of the first things when we're storing media in Azure is in terms of best practices, how do we keep our secrets a secret? So a secret is, say, if you're using, say, SQL database, you've got a username and password. Now, if you're building a client application, in some cases, you can go and store that username and password directly on the client device. But if we're talking, say, Windows 8, Windows Phone, or any other client device for that matter, if you're storing that connection string or whatnot on the device, means you're more open to being for someone going in, reverse engineering, extracting that, and then doing what they want. So one typical way that we deal with this is we use just a proxy pattern. So essentially, we use a web role or a Windows Azure website, and we store the keys up in behind the web role. So in this case, we'd proxy the request and go and dump it into storage. So this scenario here is a blob storage, so we'll say that's a file, perhaps the image we're going to do. And if we took the photo, we could serialize it up to our web role. That would have the account keys, and then that would serialize it into storage. Now, that's all good and well, but again, if we start thinking about that network I/O, we're essentially serializing a 1 meg image up through our web role. So with Windows Azure Blob Storage, there's actually a better way to do that, and what we call it is a shared access signature. So it works a little bit like this. Again, we have our account name and key for our storage account here in our web role. And we request to the web role to say, can you generate me a shared access signature so I can write to blob storage? Now, a shared access signature is essentially a time box token that allows your client app to write to storage without requiring any keys. So that will return that shared access signature, and it's in the order of like 100 bytes as opposed to 1 meg. So immediately we've removed a lot of that heavy I/O off our web role. Because now, once we've got that shared access signature, we can write it directly to storage, or if it was a private container, we could also read that private image using that shared access signature, whilst ever the time slot that we'd allocated to it is valid. So with that, we're going to go and build that so you guys can see how we can do that. So let's start with our client application. And what we're going to do is we're essentially going to use the camera capture UI to capture an image and upload it to blob storage using a SaaS. So let's put a little nice app bar on the page here. And we're going to put a button on that's just got a photo. And we're going to have a method here that takes the photo. So to take the photo, we use camera capture UI. New camera capture UI. So this is just part of the WinRT API that allows us to interact with the camera peripheral. So what I'm going to do now is I'm just going to wire in one line of code here that we'll use later when we do our notifications. And I'm just going to set an aspect ratio that's going to be of the right dimensions that we require to send a wide tile. So we'll come back to that towards the end. But that's basically what that line is doing there. Now, to capture our, I'm just going to make this an async method because we're going to call an async method here. To capture our media, it's really quite simple. We just say camera, capture file async. We say, let's capture a photo or video. It's an async method, so we want to await that. And that's basically going to take a photo for us. But now, we've got a little bit more work to do. So we're going to need to get a blob SAS and then upload the image direct. So let's build out the server. So we'll start with a web API. We'll call this blob SAS. Hit add. Right. So let's say we want this to be a get operation that is API / blob SAS. So we'll say public. We want to return a string, which is just our SAS. That will require 2 parameters. First one's a container. So that's essentially similar to a folder in Windows Azure Storage. So it's something that we can nest our images that we're uploading under. And we want to return, we want that shared access signature for a particular blob. So that's our method or our interface. Now let's drop in the code to create that. There's my Ninja snippets in action. We'll walk through the code in a second, but first we need to resolve these references. So the first thing that I'm using for that cloud storage account is essentially the Windows Azure Storage Client Library. So if we come down here, quite a ways, we can add our storage client reference there. We can control dot that such that it resolves. Actually, let's do a few control dots before we walk through the code. Now, who here has utilized this before? Any Azure developers in the room? Awesome. So, key thing that's different between cloud services and Windows Azure websites now is essentially you don't have that cloud services project because we're essentially building an MVC site to be deployed to Windows Azure websites. So since we don't have a service configuration.cfg, CSCFG now, we can't really pull a connection setting from that like you see in this commented line. So what they've created is a cool little helper that essentially what it does is it says, first, do I have my service configuration file? No. Okay, it must be a standard website, so I'll check the web config. And this is called the Windows Azure Configuration Manager. And that's this class here. So essentially, if you use this, your apps can be portable between Windows Azure websites and cloud services without having to change any code. So, what I'd like to do is create a storage account first, and then we'll walk through that. It looks like I didn't delete my old storage account here, and I've got a limit of 8 on my machine. So basically, a Windows Azure storage account is a named resource that allows you to store up to 100 terabyte of data. So at the moment, we're just deleting one that I used for a demo. You can see a few other demo ones there, but once that's done, I'm going to be able to go and provision a brand new one to be used in this particular session. So we're going to hit storage. We use quick create. Call this party. I wonder if anyone's taken that one. Look at that. No one's taken the party one yet. We're going to use West Europe. Obviously, no one's demoed this in Amsterdam. All right. Okay. So that's going to go and provision that. But while we do that, let's start wiring up our first line of code. So a cloud storage account is essentially a handle to a storage account. What that means is it lets us interact with storage, be that blobs, tables, queues, and such. So to pull this connection string, we're going to have to write that now into our web config. And it's just a standard app setting. We're going to call it data connection string. It's going to have a value of default endpoints protocol. So we're going to specify we want to do everything over HTTPS when we're talking to this storage account. We want the account name equal to party, the account key. We'll come back to that when it's finished provisioning. Let's walk through the code. It does take a little while to provision, not too long, but it's pretty decent for 100 meg. So let's look at the generation of the shared access signature. So we get a reference to that storage account. Then we say we want to really interact with blobs. We want to generate a shared access signature for a container. So the blob client allows us to interact with blobs and containers. And then we say, okay, we've got our blob client. Now I want to get a reference to that container. So essentially the folder that we're passing in from the client application. We want to store this image perhaps in my test container or something like that. So we get a reference to the container. Then we say, hey, that container might not exist, so let's create it if it doesn't already exist. So that's basically creating a container so we can store something in it. The next thing we need to do is to specify the permission set for that container. So in this case, we're using the blob container permissions. I'm setting the public access property of that to blob. So what that means is any client can address images publicly from the web, and they'll get shown or pulled down in whatever client they're using. If we wanted to make that container private, we could just set it to off. That means no one can access it unless you've generated a shared access signature for them to get at it. But when we use blob, what that means is people can publicly read it, but then you either need a shared access signature or a storage account name and key to write directly to it. And since we don't want those keys on the device, we're going to create a shared access signature. So what I'm doing here now is creating what's called a policy. Now, a policy essentially means if we're generating this token that can be used to write to that storage account, we can use a named policy that says, well, whenever you use this policy to create a shared access signature, I want the user of that shared access signature to be able to write to that resource. If we did use the version of off here, we could also pipe in a read option. And we're specifying that we want that shared access signature valid for 4 hours. You could make it 5 minutes if you wanted to, but I'm just using 4 as an arbitrary number here. But for that entire 4 hours, if you've got the shared access signature, you can write to that container. Once it expires, you need to request a new shared access signature. So we set the permissions on the container, and then we simply called get shared access signature, and we specify the policy name. That returns back a shared access token, and then I just concatenate that together to get a nice public URI with the storage account public address, the blob name, say image1.jpg, and the shared access signature appended on that. So there's my party storage account. I can hit manage keys here. So prize to anyone who can remember this? Anyone? Geez, audience participation here. No one wants to help. Right. I had someone say before it ends in double equals, so they were a developer. They did get a prize. That was in Australia. Okay, so now we've got our account key, and we've got a simple service that's going to return a shared access signature. So let's carry on with our client code. So we need to get the blob SaaS now. I've got a Ninja snippet for that. Now, what I've got here is essentially the public URI for that service. So again, it goes to API, blob SaaS, and then we're passing in this case the 2 parameters that we specified in the method, the container and blob name. So let's move this guy up here, just because I like being neat. Get rid of that so we're not scrolling so much today. It's our blob SaaS, and we want to put in the port because we're hitting localhost at the moment. That's basically our URL to that. So now we say if the media that we've captured is not null, let's new up a HTTP client. It's called getAsync to that endpoint that we defined. We're going to format that endpoint to drop in the container and blob name, and we're going to specify my test container and the media name, so that'll be like image1.jpg. If we get a successful response, then we pull out the shared access signature URL. So that's cool. The next thing we need to do is actually, now that we can write directly to storage, as I showed you in the slide that showed the 4 steps, request a shared access signature, get it back, which is what we've got up to the breakpoint then we can write directly to storage now. So to do that, we need to upload the blob. So you can see now that what I'm doing is I'm taking a file stream from the media that we've captured, and now I'm creating a stream content. So this is a special class that can be used with a HTTP client. Essentially that says, take a stream and then just serialize that to the payload when you're doing your put or post operation. So we take a stream of the media, we set the content type to be, say, to be a JPEG. In this case, that is what that'll return. And then we say, put that directly to our SAS URL. So that's going to write directly to blob storage now. It's going to serialize the content, which is that media. So let's spin this guy up. So there's our services. Machine's a little slow. Now let's start the client. Right, so this is going to show us an error, and I've done this specifically to, let me remove that breakpoint, to show you one key thing you need to do when you're integrating with device peripherals. So see that? I tried to click the camera button and it's saying, hey, you need to assign permissions for this app to use the camera. So if we come back to our app, whenever you're interacting with device capabilities, similar to Windows Phone, on Windows 8 you need to specify them. And that's in our package AppX manifest, and it's in the capabilities tab within that. So to use the camera, we need the microphone and webcam, because we're going to take some video and pictures sometime today. And now we should be able to spin that guy up, and we'll be able to take a picture, perhaps of your lovely host today, or maybe the better looking audience. So let's do that. So we're going to spin this guy up. There's my up bar with the photo button. So now you can see it's saying, can we use the webcam? Yes. Hello. We're going to change the camera over to my cool one here. Do you guys mind if I take a picture? All right. So let's focus on you guys. Nice. And then you can see there's the aspect ratio we put in earlier. So we'll come back to that. But I can like crop down here. Hit OK. All right. So now it's hit my breakpoint because it's called in and it's returned that blob SAS. So you can see that my SAS URL here is going to party.blob.core.windows.net, my test container, picture 1. You can see the shared access signature appended on the end here. If I hit F5 on this, it's going to go and upload it. I don't have a progress bar here. So let's go and use our Storage Explorer to say, let's connect to Party. Let's get that key again. Anyone remember now? Double equals. Yeah. Nice. So drop that in, hit OK. So now we've got our party here, and we can see, go into my test container, there's our picture that we just took. And we can see that right there like that. So that's pretty cool. We're already storing images up in blob storage using best practices, and we're not exposing that key to our device. So if I bring this up in Internet Explorer, you can see we can also address it without public URL. That's pretty cool. But time is running. Let's move on to the next step. Let's add geolocation. So we've got an app now. We can take a picture, get a shared access signature, upload that picture directly to storage. But I really want to know where that picture's been taken. And I want to see how I can leverage, say, Windows Azure SQL database to store that geolocation information. So we're going to build out something that adds up what I call a point of interest, because it's an interesting thing about a picture, I guess. It's where is that picture taken? And we're going to add a radial search as well that says, if I'm at a current location of, say, Amsterdam, show me all the points of interest that I've uploaded within a specific radius, which may be like 1 kilometer or 9,000 kilometers or whatnot. But it's essentially a way of shrinking the data set that's returning back to the device to only show things that are near them. But again, what are the basics of location on Windows 8 and Windows Azure? So on Windows 8, we're going to use the geolocator class. That essentially provides a means for us to find out where our location is. I'm using a laptop here. I don't have GPS, but what it will use is a geo-IP lookup. So it'll say, well, our public IP address is X, and then it'll find out what the current known location of that public IP address is. So it'll be an approximation. Storing that data, we're going to use Windows Azure SQL database because it supports the geography data type. It also supports a geometry data type. So that's one thing to note is if you want to represent a flat Earth, say bird's eye top-down view, you can use geometry. We're going to utilize curved Earth. So all calculations that we're making take into account the curvature of the globe. So the distance from point A to point B, if you're using curved Earth, and it's a long distance, is actually further than if you were just looking, say, top-down onto that. WKT, well, that's well-known text. It's just a nice way to represent a location or a point just in a string. The ST distance operation is an operation on the geography data type that says essentially if we want to find the distance between point A and point B, we can call just like that and it'll return back the distance in meters that they are between the two. And lastly, if we want to convert that nice well-known text into a geography data type, we just use ST point from text. So I've put a link up there for more information if you want to go and read that. But let's add location to our application now. So this one is quite involved. So the first thing that we're going to do is we're going to start with our SQL Azure database. I just said SQL Azure. That's where the marketing guys sort of come down from the ceiling and ninja kick me in the face or something like that. All right, let's. We called it party, didn't we? Party DB. So I'm going to choose a server, of which I believe this is East US. It is listed there if you select it, but when you create a server, I created one earlier, it essentially gives you an arbitrary string as the name such that there's not conflicts. So let's hit OK. We're using a 1 gig web edition. We could go 5 gig. We could go to business and go up to 150 gig. If you need more than 150 gig, we've got what's called SQL Azure Federations. And that allows you to essentially shard out that data and exceed that 150 gig limit. But there's our party DB. That was pretty quick to write, to go and create a database in Azure. We can store up to 1 gig in this off the bat. So we're in there. We can say, what are our connection strings? We've surfaced connection strings for ADO.NET, ODBC, and such, and other clients if you want to use PHP or Java. But the key thing that we do is first whenever we provision a server, we lock it down such that only your Azure services can access it. If you want to be in this mixed mode where I'm developing on my local machine here, but I'm consuming cloud resources, you need to add a firewall rule here for our network to be able to go and connect out to that over port 1433. So by default, it's locked down and secure. You can see here that it shows your current IP address, and I've actually gone and done this before, and I've just opened up the whole range, because sometimes, depending on the networking, that IP address there might change. But so we're fine there as far as the firewall rules are concerned. So let's go back to our party DB and grab that connection string. So we're going to grab that. That's our server. Going to come over into Server Explorer. Let's add a connection. So now we're going to connect directly to that server from Visual Studio. Now we can see our party DB there and a few other test runs I did today to make sure I don't make mistakes. It's still quite possible. Right, so there's our empty DB. Now we want to execute a query against that. So we're going to create our point of interest table and a couple stored procedures to return data from that. So it just so happens that I've got a handy bit of script here. Let's have a look at it. So first thing, create table. The two key things here is you can see that we're using the geography data type to store a location, and we've got a URL here that we're going to use to store the blob URL, that public URL, where that image is stored. So essentially now we've got a blob associated to a location. The next thing we've got is a create procedure here, which does a get points of interest radial search. So this is how we say, return to me all locations that are within a particular range. We're using well-known text to call into this from our service tier, which we're just about to build, and we're giving a radius in meters. And basically what we're doing is we're selecting from our point of interest, and we're using that ST distance method that I told you about to say any of the location columns in that table that are within a distance of the origin that we pass in, where that is less than or equal to whatever our radius. So if we said 1,000 meters, it would find all locations that are within 1,000 meters of this origin. The other thing that we've got is we actually need to populate this table somehow. So I've just created a basic insert point of interest table. And we can insert that directly, those values then directly into our table. And it looks like I've put in just a default point there just for fun. Right, so let's close that. I didn't execute it, did I? Let's run that. There we go. That would have been fun. All right. So now we've got our table scaffolded. So if we expand this, you can see we've got that, and we've got our stored procedures. So some people may be asking, why aren't you using code first and EF migrations? Well, since Azure isn't supporting .NET 4.5 at the moment, because it's not GA, we support .NET 4, so I'm using Entity Framework 4.3.1 in this scenario. So let's clean that up for a second. So what that basically means is Entity Framework 4 does not support the DB geography data type. So I can't use EF code first, which is why we're building and scaffolding our DB using T-SQL instead. So I'm just going to remove Entity Framework, which you'll see here is an RC version of 5 that it drops in by default. I'm going to install package, and it'll be entity keys. Fingers not working that well. And there we go. You can see we've just dropped in 4.3.1. So that's that. So let's generate our data tier. Just going to add a new item. We'll select data and use an ADO.NET data model. We'll generate that model from the database. That's our right connection. Let's just provide a name here. We'll call it location entities. Hit next. Now I only really want to map the stored procedure here, because you'll see if we look at this, there's our point of interest table, but we're not really going to be interacting with that directly. We're just going to use the 2 stored procedures. Name this model, hit finish. It's going to go and generate essentially my data tier to call into those stored procs. So any questions while this happens? No? All going good? Happy? Awesome. So there's my data model. So one thing that I like to do here is to add a code generation item. And in this case, I'm just going to put in a nice strongly typed DB context. Because this essentially makes a DB context that we can use to talk to our DB, and it's a lot cleaner than the default one in 4.3.1 that you have if we didn't just add this. So that's going to add that for us now. Because I'm sometimes pedantic, we're going to look at this get points of interest radial search. So this is wired it all up for us, but I don't really like the type that stored procedure is returning. I don't like the name. So you can actually come and change that, and we're going to call this point of interest. Because if you recall, our get points of interest radial search returned back a list of points within a range. So let's generate that guy. Hit save. So if I come back to my solution now, we can see that we've got our DB context here. It's called location entities. Get rid of that guy. We've got a get points of interest, and we've also got an insert point of interest method. We've got a nice point of interest class here that's generated based on the return type of that. So that's good. So now we need to expose that get points of interest radial search, and we also need to expose that insert point of interest so our client application can call into that. So I'm going to add a controller for that, and we'll call it our location controller. It's going to be an empty API controller. And we'll drop in a snippet here. So let's have a look at this. So this is essentially the next step up on our data tier. We're going to use the location entities type that we've just generated. We've got a post operation here to post up a point of interest from our client. So that comes up, and then we use the well-known text format that we talked about, and we drop in the latitude and longitude of that point of interest, and then we insert that directly to the DB. Now the reason we're using well-known text here, be it a string, is again because that DB geography data type isn't supported in Entity Framework 4.star. In Entity Framework 5, this becomes a lot cleaner for you. So let's carry on, but this just calls into that stored procedure and inserts it, so it's quite straightforward. If we want to have our radial search here, it's a get, and we pass in an origin, latitude, and longitude, and a radius in meters. So to execute that, it's as simple as calling into DB, get points of interest. Now we require an origin, well-known text here, so that's how we define the stored proc. So we'll format that string, and we'll call well-known text as our field at the top. that we've defined that template in. Now this one always gets me. It's longitude then latitude when you're representing a point in well-known text. And that's passing the radius in meters parameter. That's basically going to now return a list of points of interest. So that's cool. Is it? What do you guys think? Plenty of code? Hopefully not. Is it boring you or is it cool? Awesome. All right, well, hopefully I won't make mistakes. All right, so let's work on the client now. So I like to start, you notice that I sort of, when I'm working on server sides, I typically like to work bottom up. And when I work on client sides, I sort of like to work top down, just because it provides a good framing for me. I guess everyone's a bit different, but that's how I work. But what I want to do in my client app now is I want to represent these points that we're capturing on a Bing map control. So we've actually got a beta one of them available for Metro applications. You can get it from Visual Studio Gallery, but essentially that's it here. So one thing you need to note with this, though, is that Bing map control is, for all intensive purposes, a beta at the moment. So one of the things that it requires is you to specifically specify a target platform for your client application. Otherwise, you get a build error. So that's basically why I just did that step. But if you forget, it's going to tell you that you need to specify that. So we'll add a reference to the Bing Maps control, and it takes a dependency on this runtime here. We'll hit OK. So that's going to reference that so we can actually use it in our application. So let's update the XAML here. Say, let's define an XML namespace. My keys are off there. We'll call it BM for Bing Maps. We'll say using bing.maps. And there's our namespace. So now we can drop in a Bing map control. So the first line here is essentially our Bing map control. We've set a default zoom level, and we've set a credential to be able to call into the Bing map API, which returns back like the tiles that are rendered to show you the map, be it whether it's just a standard map or whether it's satellite view or whatnot. I've also got a couple more things on here. I've got an image and a media element, and we're going to use those to essentially show the photo that we've taken or to show the video we've taken when we click on a push pin. So we'll click on a push pin on the map, we'll see the photo or video, but then what I want is when I click on that, because I want to use the app again, I want to tap on the image after it's shown, and then I want to hide it. So let's just wire that in quickly, and then we'll get onto the geolocation. Sender as UI element uint dot visibility. Let's just set that to collapsed when we tap on the image. Right, so let's deal with geolocation. So we're going to use the geolocator class. Geolocator, control dot that guy. It's added a using statement in for me. Who here uses control dot? It's awesome, isn't it? It's like, okay, so for those of you that don't, essentially if you don't have a using statement for something, you can hit control dot on that, and then you can either do the fully qualified name, like that, or you can do the dot, and it just goes and adds that in there. Essentially, it just saves you keystrokes. But let's name this geolocator. There's our geolocator class. So what we want to do is we want to know when our position is changing. So let's wire into the position changed event. So there we go. So if our position is detected as changing, it'll fire this event handler. Do a little bit of async magic in here. And code snippet. Pretty cool. So because I'm a forgetful kind of guy, it's like I got to put in these little reminders to myself. So unlike the camera, and this may get you too, unlike the camera when you click it, if you haven't defined that capability that we've seen, it actually warns you. But with the geolocator, there's no UI to say, hey, you forgot to define the capability. So it just goes to like initializing state, and then you never get any location data back. So if you're observing that, then you've probably forgot to come in, click on the capability, and specify that your app uses location. So that's that. So let's have a look at this guy. So what this is using, it's saying, when the position changes, I want to execute on the UI thread. So I use a dispatcher, this method. And what this method is doing, it's saying, create a new location type. So this is from the Bing Maps namespace. And take the latitude and longitude that comes in as the argument, and create a push pin, set its position on the map, and then add that to the map, then center it around it. So we're just adding a me location so we know where we are. So let's control dot these properties, and we'll come back to this later. So we now know where we are. We're going to have a me button. This get points of interest is going to be our radial search, but a radial search is of no use if we don't have any points. So we're returning to our take photo operation here. So now we've taken the photo, we've got a shared access signature, we've uploaded that to blob storage. Now I want to add a point of interest to that table. So we're going to add the point of interest. Let me just add this up the top here because I'm pedantic. And that's going to call into our API location controller, which we defined earlier, to have the add point of interest post method. So now we're down and we need to figure out how we go and create a point of interest and upload it. So the first thing I'm going to do is use data contract JSON serializer. So I'm going to push that data up to my service in JSON format rather than XML. And it's going to use a type of point of interest to serialize that. But our point of interest is defined on our services. So there's our point of interest there. Now if we come back here, we say, well, how do we get at that from the client? We could add a new class altogether, but that's going to present, say, problems. For instance, if we're going and changing, say, that point of interest on the server side, it's not going to be reflected on the client. You could go and externalize that into like a core or common API. For the purpose of this demonstration, what I'll do is I'll just use add as link. So we use existing item. We click back up from our client into our server. We select models and we select point of interest. We say add as link. So this is actually a file link. So I've clicked on that and you can see now it's gone down to the server. So any changes that happen on the server component are instantly reflected in our client, and we don't have to change any code on our client app. So I can just resolve this now that it's referenced. So what we do is we say we've got a serializer that can serialize a point of interest. Let's create it. So our point of interest has well-defined properties, a description, a latitude, which is going to be our current location, and we've got a URL, which is our SAS URL. So that's essentially going to give us where was this photo taken and what's the public URL for that. Then, as we did before, when we posted a stream to blob storage, this time we're going to post it to our location controller. So let's take the memory stream that we've got off the serializer. So we've essentially said we've got an empty memory stream here and a serializer. Let's write this point of interest to our memory stream and then use that for our stream content. We want to ensure that we're telling the service we're using a JSON serializer, so the data that's being pushed up into our point of interest is JSON. So that will then allow Web API to figure out, hey, that's JSON, and then it will go and deserialize that for us without us having to write any of that code, and then it'll pop right in here as a nice little point of interest. So we do that, and then we simply call post, because that was a post operation, and we point it at our add point of interest URI, which is at, up here, API location. Great. So if that's successful, a little optimization I've put in here is to say, if we posted that point of interest properly, rather than having to call to the server to get all the points back again, let's just drop that push pin onto our Bing map control. We can do that using a simple method. Add push pin. So we just new up a push pin, and like we did when we added the me, we just add it to the map. But we want to add that tapped operation. So when I click that, I want to see what image is actually there. So you can see the key thing I'm doing here is I'm specifying the tag of the push pin to contain that public URL. And that's the public URL of the blob. So when I tap it, I essentially say, let's extract that URL from the tag of the push pin that we added there earlier. If it's a JPEG, let's show the image. If it's not a JPEG, then it's going to be a video, and let's show that. So what else am I forgetting? We had one last thing to do. So that gets us push pins. That gets us the ability to take a picture, associate a location with that, store that in SQL Azure, add a push pin to the map. But when our app runs for the first time, we want to get all points of interest that are within that radius of us. So that's what this get points of interest is going to do. And we're going to call that every time the position or our location changes. So get points of interest. I know this one's a long demo, this particular one. It's just because there's quite a few moving parts. But it really is quite cool to see. Hopefully in an hour and 15 minutes we're going to have a pretty cool app working that's consuming resources from Azure. So it's quite powerful to see that in action. So I'm going to resolve the references. So our get points of interest is calling into our location controller. That's the method we wrote here. It takes latitude, longitude, radius in meters and returns the IEnumerable point of interest. So when that returns, essentially says, well, now we need to get that IEnumerable point of interest out. So we read the content of the result as a stream. We use data contract JSON serializer again, but this time with a type of IEnumerable point of interest. And then we read that out and cast it to the appropriate type. Now we've got a list of those points of interest. The last thing we do is we iterate through them, say let's drop all those push pins on. So for those of you who've used the Bing Maps control, perhaps in a browser or in Windows Phone, at the moment the beta doesn't support data binding. So that's why we're doing it in code behind like this. So that's an important point to note. It's probably worth checking the release notes of it when you go and use it to see if it does support data binding. But for now, that's not there yet. So let's spin this guy up and cross our fingers. We should be good. So we're going to spin up our services there. Takes a few seconds. And let's spin up our client. Got a network connection, so we'll be able to get our IP. Now, I think there's going to be something funny happen here. We may not show up in Amsterdam, but we'll talk about that in a second. It's saying, can we use our location? We hit yes, and we're in Houston. Awesome. So what's happening here is essentially there's some satellite trucks out back of the conference, and the network that comes from here goes into those trucks, goes via satellite to Houston, and that's where our public IP address is. I'm pretty sure that's what's going on there. So that's why the geo IP lookup is saying Houston, and that's a good thing for you guys to take away as well, is geo IP lookups are only as good as the public IP and whatever information we have about all those public IPs. So in this case, we've got Houston. Obviously, if you're using GPS, it's going to be significantly more accurate than this case. Yeah, well, there you go. Everyone got to come to Houston today. So there's me. Let's take a photo. Are we going to allow it to use webcam and microphone? Yes. The reason it asks this every time at the moment is because we're just in debug mode. Whoa. If you are, let me get rid of this. If you have this deployed as a real app, it only asks the first time. But let's take perhaps some video this time of the audience. Do you want video or picture? What do you get? Video? All right, so we're going to click video mode. So the camera capture UI is pretty cool in that this all comes for free. So we've got video mode. Now, at Microsoft this time of year, it's review period. And if you're liking this session, I'm going to give this video to my manager. You can applaud. If you... Oh. I'm not recording yet. I'm not recording yet. Yeah, that wasn't good enough. We need it better. So applaud if you're enjoying, and wait, I'll tell you when we're starting. Or boo if you want to boo. That's also cool. Okay, so I'm going to click. There we go. So awesome. All right, yep. Thank you guys. Audio isn't that great. That's it okay on that. And that's going to go and upload that for us. So you can see now that that video has been uploaded. And if we click on this, we can see our tap operation. Take a second to pull it down from blob storage. Yep, so there you go. Thank you very much. All right. Awesome. Oh, sorry, I can't hear. I've got one in every city that I've been in the past few days. Yes, but you guys were by far the best at applauding. Right. So that's basically it. We took a picture. The radial search didn't return much because we had no data there to start with. So let's spin it up now that we've got that picture or that video, and we'll see that that radial search now is going to return that point and put it on there for us. And then we'll move on to push notifications, which I think we can crank out in 14 minutes. So now you can see it's called into that radial search API. We've got the video there on some street in Houston. You can see that I've moved around a little bit there. Awesome. So with that, let's do our push notifications. So push notifications are essentially the way with Windows 8 we can go and light up this start screen. So this is basically the gateway to your application. If you're developing a Metro-style app, users will come here, they'll see hopefully relevant and up-to-date information, and that will essentially draw them back into your app. So push notifications are quite a powerful way to engage with your users and ensure that they're coming into your application again. If you're monetizing it using advertising perhaps, well then that's a great benefit for people going in and using your app. If it's a paid app, well, perhaps they want these features by default because they've paid for your application. But if you cast your eye across the screen, basically what's happening is, in my case anyhow, I don't know about you guys, but my attention is drawn to those apps with the tiles moving around. So we'll have a look at how we can build that out in our application here now. But the first thing I want to show you is essentially what's the life cycle of a push notification. So the first thing is everything in blue is what we code as developers. Everything in green is what Microsoft provides for you free as part of the platform. So the first thing we do is our Metro-style app here. If I may, there we go. Our Metro-style app requests a channel. So a channel is a way to uniquely identify that application such that you can direct, say, a tile or toast notification to that start screen. So we request a channel. Next thing we do is we take that channel and we register that with our cloud service. If we were building a weather application, it'd be perhaps our cloud service is monitoring some weather APIs to determine when the weather's changed, and then it pulls that channel out that we've just stored. And of course, what it does then is composes a notification to send. But to do that, it's a two-step process. You need to authenticate against WNS, and then you need to push the actual notification payload to WNS, which is the Windows Push Notification Service. They dropped the P from the acronym. I'm not sure why, but it makes it easier to say. But then I've got to explain it all, so I'm not sure if that's actually valuable or not. Right, but then we push the notification, and the Windows Push Notification Service, which is free, then deals with delivering that notification, and the notification client platform deals with surfacing and rendering that. So you really don't need to get into the complexity of how is that rendered on the client side. You just need to be able to talk to two APIs, this one here, and your own API for storing your channels. So that's basically what we're going to build out now in 11 minutes. Right. So firstly, if we do run to that 11 minutes, I'll be available for questions like immediately after. We may just sort of step to the side so the next presenter can come in. But yeah, we're definitely covering a lot of content here, so I do apologize that we're going to run right up to the minute. But to send notifications, we need a few things configured on the client side. So the first one is if we want our app to support wide tiles, we need to add a default logo. So you can see here my first attempt on the left of making something interesting for a default logo versus my one on the right. So we'll select that guy. Next thing, if you want to support toast, this typically gets people, you need to specify that your app is toast capable. So that's part of the client portion. The next thing we need to specify is our package name. And this all ties into the auth piece that WNS performs. So I need a few credentials for this. So I've actually pulled them into a snippet. If we go here, you can see manage.dev.live.com/build is where I requested these. And here's it. You go in, you fill out a wizard, and it returns these values, which you can then use for the auth step. So let's remove that now and drop this in here. So that's our first piece. Now, because I am a lazy developer and I like to make it easy for other developers, I've created a NuGet package here. And what this NuGet package does is it essentially makes it really easy to perform those first two steps, which is to request a channel. We're not up to Windows 9 yet. and it's called Windows 8 Notifications. It allows you to request that channel and then post it to your cloud service in 2 lines of code. So it just abstracts that away a little bit for you. So let's write the code to use that. On Navigator 2, hit close, 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 close. I probably shouldn't have closed all them because I want them later on. Where's my on Navigator 2? There it is. So let's get rid of this basic 101 that we did, and let's say notifications client. We build after dropping in that NuGet. Control dot on new. I think I spelled that wrong. There we go. So that's this, our client. We say client is equal to new notification client. Now I'm going to specify this is like, we'll call it party, so that's our app. So this is just for storing the channel on the server side. Your client ID may be like their unique ID that comes back from the live API if you choose to use that. And where are we going to register this endpoint? It's going to be on local host. Does anyone remember the port? Come on. Alright, there we go. I'm just going to drop that at endpoints. So that's our client. Now we say client.register, and we're going to call this guy main app tile, because of course you can pin multiple tiles. So that's our client side done. Let's do our server side. So if you recall, the next step that we had, we've just done this, and we've just pushed it up. So we need to write that service that we take that channel and store it. So again, for this, I've got a nice little NuGet package, and this is where I want to now see my Windows, which I closed. View, where is it? Tools, Package Manager Console. There we go. So let's set the target now to the server. Say install package Windows Azure.notifications. So this drops in a web API. You'll see it start dropping folders in here in a second. But basically, it accepts that channel and stores it into table storage for us. Yes to all. I drop in documentation for those that want to sort of reproduce this later on. And you can see now we've got an endpoint controller. That's an API controller there. And it's got a put operation for accepting an endpoint. So now that's that. So let's hook this into our location controller here. So basically, I add a point of interest after I've uploaded the image. So I upload the image, then add the point of interest. So this is a good place because we know that the image will be there to create the tile image and send it. So what I do is I just kick off a task to run in the background here. You could enqueue this into a queue if we had more time. But what we do is we create a thumbnail image and then we send a notification to that. So thumbnails are not too interesting. So we'll just ninja snippet it in the next 7 minutes, 57 seconds, 6 minutes. Resolve that reference. Now let's resolve the memory stream. So basically what this does is it reads the image from blob storage and then thumbnails it out and then writes it back as _thumb on the original file name. Of course, the last thing is what's the blob URL we're passing in. It's that. So let's remove that. Now, this notification controller which we dropped in, one thing that it does is I externalize all the config into one file for you, so you really don't need to look at all that other code. So we're just going to tell this to use our real storage account, and we use the Cloud Configuration Manager, get settings, same as we did before when we were generating the SAS. Say data connection. I'm sweating now. Data connection string. It's a good thing they're not recording, otherwise my manager could laugh at me. Right, so that's wired that up to store it in our real storage account. So moving back, so now we've got a tile, we've got a channel stored in our storage account. We now need to be able to send that notification. And to do that, I've created another handy little NuGet package here that essentially it makes it easy to generate all those different template types. So there's 50 different notification template types that you've got. And you know, if you want to use a lot of them, that can take time. So I can created what I call the WNS recipe. It's just a nice managed API for newing up, say, a toast notification and sending it. So that's that. Let's put in the few last steps here. So the first thing we need to do So we need to say how we're going to do that auth that we talked about as part of the last step. And we'll call this iAccess token provider. So sending notifications is actually two-step. You authenticate against WNS, and then you send your notification payload. The token provider does all the auth step for you. Geez, typing and talking, I tell you, difficult. There we go. So we knew that up, and this is where the other two pieces of that security or secret that we had from manage.dev.live.com/build come from. So the first parameter here is going to be our client ID, or package SID. Drop that guy in there. Remove white space. That's a common problem people have, is white space. Maybe I should just update the recipe to trim the white space. That's probably save me a few emails. Make life easier for myself. That's what's cool about programming, I guess. But right, so let's send this notification. So, as part of that Windows Azure .notification endpoints API that we've got there, we configured the notification service context within here. Now, if I jump back, what we've got on there is a property that essentially exposes that storage provider that we've got so we can retrieve back our list of channels or endpoints. We iterate through them, and this is where, the WNS recipe comes into play. We use tile content factory to new up a new tile. So you can see here, there's a lot of different tile templates. We're using that one. We set the image source to our thumbnail URL. We set the text to some text. Now we create a small tile because essentially, if you're running an application here, people can come and set your tile to smaller, but you don't know that they've done that. There's no API to show that. So essentially you have to send wide and square tile at the same time. So we do that. So we create the square, and we just set square content on the wide tile. Then we call send at the channel URI and pass in our token provider, which we newed up the top. So all going well, we will get a notification in 2 minutes and 46 seconds. Any questions while we spin this guy up? What do you guys think? Sort of cool? Yeah. Don't say that until it works. I actually had a typo last time. I typed location rather than localhost, which obviously didn't play well for the registering the channel. So we're going to use our webcam to take a picture, and I think we'll take a picture of you guys. So I think we took this side at the start of the day. So let's take the other side there now. So does anyone want to wave? Going to be on a tile. Oh, well, yeah, nice and blurry. Camera was changing while I took it. But let's do this. Hit OK. So now that's going to upload our picture to blob storage using a shared access signature. Should come over here. It's then going to thumbnail that image after it adds the point of interest. And hopefully, if there's no errors, which it's looking like there may be, we might get that tile. Oh, man, and it was going so well. Okay. Let's put a breakpoint there just to see that we're getting it. Got a few seconds, a few minutes. Location controller, drop it on the result there, on the for each to make sure the channel's getting up. And let's go back to our Metro app. Oh, there it is. Ta-da! Thank you. All right, so that's pretty cool. So let's close up in 1 minute. I can't believe I'm pulling this in time. I'll show you this slide, which I originally pulled out because I thought we wouldn't have 55 seconds left. But these are the next step for your tile notifications. Handle the result that comes back. From that, you can see if the device is connected or not. You may want to push the notifications from a worker role and in-queue that original message to create the thumbnail and such outside of your web tier. There's a bunch of different template types here. We've got bit.lys to them, and they're all the NuGets that I utilized. So if I were to click on, say, this bit.ly here, you can see that these are the different tile types that are supported for Windows 8. And as you can see, it's a very rich set of tiles there, which basically means you can surface information however sort of best fits for your application. Right. So, in summary, we've in 1.25 hours, we've created an app that shows basic connectivity, takes a picture or video, uploads that to storage using a shared access signature. We store location-based information on that such that we can query that data and get data back or pictures back or links to them where they're near us, and we added push notifications. So we all did this in that short amount of time, and that application is now ready to publish to Windows Azure websites, as you saw Scott Gu do in the keynote. So with that, thank you very much, and I hope you enjoyed. All right, so I'll out of the way, but if anyone's got questions, please feel